Hi, I'm Lila, and today I'm talking with Dianne, and we're going to be chatting about the activity lifecycle. So, Dianne, could you start off by saying what you work on?
Yeah, I manage the framework team at in Android. Sometimes describe it as we take Linux and Java and turn it into Android.
So, right now, for you, what is the most exciting thing about being a developer of Android?
There's very few places where you can actually work on an operating system that actually matters. Like there's very few like successful operating systems that really have an impact. Android is like has about the biggest impact you can hope for. It's the biggest operating system I think ever. Um, and so being able to be involved in that is just a once in a lifetime opportunity.
Now, Dianne, you've been working on Android for a while. What were the major concerns back when you started working on Android, and what are the major concerns now?
We wanted to build a mobile platform that would work on existing hardware, which was pretty low end. The G1 had 100 megabytes of RAM available to everything, so very very limited. But we wanted to have something that could scale up to the future. And the challenge now is just Android is so big. It's like managing this huge ecosystem of all these different people involved and keeping it going and making sure that the wheels don't fall off is like people try to do all kinds of different things with it is a big challenge.
So, where did the concept of the activity actually come from?
Unlike a desktop, you want to focus on one thing at a time. The user is in one application at a time. It's very focused. The applications do very limited set of things, like it's your contacts application, your to-do list application, your camera application. And they don't want to think about starting and stopping applications and like complexity of switching between them and how they can connect between them. So the activity basically was a way to represent that model for applications developer to implement those kind of things. That's a little abstract from what's actually going on. So the system can then manage what's going on behind the scenes without the user ever having to think about like, I want to start this application now. I need to stop this application because I need to run some other application.
So, in many ways, activities and fragments share a lot of similarities. So, why did you invent fragments, and what could activities not solve?
We saw applications getting more complicated. And then we were working on Honeycomb, and Android Honeycomb was the first version of Android that was worked on tablets. And so you have a much bigger screen on a tablet, and now applications are really like you expect it to do a lot more. And like anything, and all the stuff it can do, like you hopefully get on that one screen because you have all the space to do it in. But for developers, this becomes really complicated because like, well, now I have this tablet UI that I have to build all these different pieces together, and I already have my phone UI that's split up between different things. Now I have to maintain two different things? So it was like it was getting really complicated for developers. So fragments were introduced as a way to help developers kind of decompose their application into different pieces that wouldn't actually be managed by the platform. So you don't have to like directly coordinate like activity lifecycle stuff with the platform. They're just to help you inside your application organize it. And so by doing that, you can do you're a lot more flexible in what you can do in those different pieces. So you can like you can make a bottom row on your application that when you tap on it, you're switching between fragments, which is really easy. But for activities, that's like doing that with activities because they're like kind of big full screen things, it doesn't really work very well. So fragments then were like kind of like to help solve this problem of like increasingly complicated UIs and bigger screens and helping developers compose all the different parts of their UI in flexible ways.
So, when the OS is resource constrained, why do you choose to destroy the entire app process as opposed to destroying just one activity?
So the reason for killing the entire process is because when the operating system becomes low on resources, you're really typically deep in the kernel. And the kernel is basically saying like, hey, someone needs some RAM now. And it's like, okay, well, I need RAM, but I don't have any RAM. I need to get it from somewhere. So at that point, you're really like, you need to get it from somewhere really quickly. So if you were to say now, you have to go to some application, say like, hey, application, you're like, I don't really need your activity anymore. Could you kind of clean it up for me? And I'm not sure how much RAM I'm going to get from it, but hopefully it'll be enough. Then you're in a really bad situation because like you're really needing that RAM, but you're now dependent on like applications being really well behaved and really fast about getting it to you. So it kind of that leaves the system in the real bind. So instead, what you decide is like, well, hey, like the kernel is really, really good at taking all the resources of the process, throwing it away, and making them available elsewhere, and like not worrying about like nicely cleaning up things. So let's just let it do that. And let's say like when the application is now, we can get it into a state where we actually don't need the process anymore. So if at any point the kernel says like, I need RAM now, it can just basically throw away that process, not touch the application at all, and get that RAM to use elsewhere.
Okay, so Dianne, thank you so much for talking to me, for talking to our students. And do you want to get some coffee?
That sounds great.
Yeah, let's do it.
Okay.